Given this question, we are expected to integrate integral negative 1 over root of 3 to positive 1 over root of 3 x to the power of 4 divided by 1 negative x to the power of 4 times cos inverse of 2x divided by 1 positive x squared times dx. Now let me take this quantity to be equal to I. Now I would like to make the following substitution. Let x be equal to negative y. This means dx is equal to negative dy. So this integral is going to be rewritten as follows. Integral. Now when x is equal to negative 1 over root 3, the value of y is going to be 1 over root 3, and this is going to be negative 1 over root 3. Okay, the limits gets changed. Of course, over here you are still going to have y raised to the power of 4. There is not going to be having any impact with regard to the negative sign because of the degree being 4, followed by 1 negative y raised to the power of 4 multiplied with cos inverse of x is equal to negative y. So it's going to be negative 2 times y divided by 1 positive y squared times dx is negative dy. So you have a negative sign there. Now because of the negative sign, and all these functions are even, so what I can do is I can flip the integral as negative 1 over root of 3 to positive 1 over root of 3 y raised to the power of 4 divided by 1 negative y raised to the power of 4 times cos inverse of, I will retain negative 2y divided by 1 positive y squared times dy. Okay, now the next step is going to be the crucial step. Okay, so of course you have I there. What is the next step? Now we know a very important formula. What is that? Cos inverse of negative x is equal to pi negative cos inverse of x. So by this formula we can rewrite cos inverse of negative 2y divided by 1 positive y squared is equal to pi negative or cos inverse of 2y divided by 1 positive y squared. So this is the all important transformation that you will have to apply. So if I were to apply that, I would now have I to be equal to integral negative 1 over root of 3 to 1 over root of 3 y raised to the power of 4 divided by 1 negative y raised to the power of 4 times pi negative cos inverse of 2y divided by 1 positive y squared times dy. I can distribute this y raised to the power of 4 divided by 1 negative y raised to the power of 4. So that's going to give me pi times integral negative 1 over root 3 to positive 1 over root 3 y raised to the power of 4 divided by 1 negative y raised to the power of 4 times dy, followed by negative integral negative 1 over root 3 to positive 1 over root 3 y raised to the power of 4 divided by 1 negative y raised to the power of 4 times cos inverse of 2y divided by 1 positive y squared times dy. Now I'm going to change the variable y to x. No harm is going to be done. So this is going to be equal to pi times integral negative 1 over root 3 to 1 over root 3 x raised to the power of 4 dx divided by 1 negative x raised to the power of 4 negative integral 1 over root 3 to positive 1 over root 3 x raised to the power of 4 divided by 1 negative x raised to the power of 4 times cos inverse of 2x divided by 1 positive x raised to the power of 2 times dx. Now you just check this with a given quantity. What do you have here? Are they not the same? So I'm going to replace this as negative I, and you have pi times integral negative 1 over root 3 to positive 1 over root 3 x raised to the power of 4 dx divided by 1 negative x raised to the power of 4. Of course you have I on the left side, so I'm going to push this to the other end. So that is going to give me I added with I is equal to pi times integral negative 1 over root 3 to positive 1 over root 3. Let me go and check the quantity that I have left with. So x raised to the power of 4 divided by 1 negative 1 negative x raised to the power of 4 times dx. Okay, right? This is what we have got. Okay, fair enough. Now what I wish to do is I'm going to adopt a slight manipulation. Now okay, for the time being I will retain it as 1 over root 3, negative 1 over root 3 to positive 1 over root 3. Now this is going to be rewritten as negative 1 positive 1 over 1 negative x raised to the power 4. So if I were to do this, I will get a negative 1, right? And there is a positive 1, they get cancelled. Okay, so this is the exact equivalence of this, or this is the exact equivalence for this, or vice versa. So this is what we have got. I can rewrite this in this fashion. Okay, no harm is done. So now I can rewrite this as pi times integral negative 1 over root 3 to 1 over root 3. This is going to be dx. Okay, followed by positive pi times integral negative 1 over root 3 to positive 1 over root 3 dx over 1 negative x raised to the power 4. So we have to integrate this. Now if I were to integrate this, I get pi times of x negative 1 over root 3 to positive 1 over root 3 followed by pi times negative 1 over root 3 to positive 1 over root 3 dx divided by 1 negative x raised to the power 4. Now this is pi times, I substitute the upper limit, I substitute the lower limit, right? Excuse me. So this is going to give me 2 times pi times the root of 3. Okay, this value is there. Okay, so with this we will have to integrate this quantity, right? So we have there isn't any change in the integral, is it not? The only thing is that there is a negative sign here, so we should have retained that negative sign. So if I were to place a negative sign, this will have a negative sign and we will have a negative here. Okay, good thing we spotted that out. So followed by pi negative 1 over root 3 to positive 1 over root 3 dx divided by 1 negative x raised to the power 4. Now this is an even function, so I can rewrite this as 2 times pi integral 0 to 1 over root 3 dx divided by 1 negative x raised to the power 4. So now we will have to focus on integrating this quantity. Okay, so let us see how to integrate this. This is already done, so I will just consider. So I'm going to come back because there is a 2y on the left hand, there is a 2y, so I will take this as a sum 2 and I will just consider 2 pi integral 0 to 1 over root 3 dx over 1 negative x raised to the power 4. So we need to integrate this quantity. So what I wish to do is let me check the pi out. Okay, so we do have a pi, is it not? We do have a pi that is moving in. Okay, alright, so this is equal to 2 times pi integral 0 to 1 over root 3. Now can I rewrite this as 1 positive 1, okay, positive x squared negative x squared times the dx. So already there is an addition of 2 there divided by 1 negative x raised to the power 4. Okay, now positive x squared negative x squared gets cancelled, but there is a 2 there, so I will have to counter it with the 2 in the denominator. There is a 2 coming in, so I will have to counter it in the denominator. Okay, so now this is equal to 2 gets cancelled, so I will have a pi integral 0 to 1 over root 3. Now the denominator, this is of the form 1 negative x squared times 1 positive x squared. Okay, so I will have to suitably place the quantities. Okay, so first quantity I'm going to have it as 1 positive x squared followed by 1 negative x squared, okay, multiplied with dx. So this is how I'm going to write the quantities as. So this is equal to pi times integral 0 to 1 over root 3 1 positive x squared divided by 1 negative x squared times 1 positive x squared times dx positive 0 to 1 over root 3 1 negative x squared divided by 1 negative x squared times 1 positive x squared times dx. So 1 negative x squared, 1 negative x squared, 1 positive x squared, 1 positive x squared goes up, giving me pi times integral 0 to 1 over root 3. You have a dx divided by 1 negative x squared followed by 0 to 1 over root 3 dx divided by 1 positive x squared. So we can just, this is easily integrable, right? But this one we will have to consider this one. So I'm going to consider integral 0 to 1 over root 3 dx divided by 1 negative x squared. So this is equal to integral 0 to 1 over root 3 dx divided by 1 negative x times 1 positive x. Now this is easily, we can split it using partial fractions. So if I were to split it using partial fractions, this is going to be equal to 1 over 2 integral dx over 1 negative x, right? So what I'm going to do is let me write it first like this: 1 negative x positive or 1 over 1 positive x, okay, times dx. So 1 positive x goes here, so 1 positive x goes here, and followed by 1 negative x divided by 1 positive x times 1 negative x. So clearly negative x positive x goes away, 2 is there, that 2 is neutralized here, okay? So this is going to be our integral. This is reduced, or this is rewritten in this fashion, okay? Of course you have a parenthesis there. So what I wish to do is I will have to bring in this dx inside, okay? So this is equal to 1 over 2 times integral dx over 1 negative x positive integral dx over 1 positive x, okay? So now if I were to utilize a log, this is going to be 1 over 2 times, this is negative ln of 1 negative x positive ln of 1 positive x, okay? This is what we've got. So this can be further rewritten as 1 over 2 is there, ln of a minus b, so ln of 1 negative ln of 1 positive x divided by 1 negative x. So this is what we have. I hope you are watching it. Okay, so I will write this in the next side. So for now, we in place of this, you see that we started like this, and this is what we've got. So I will rewrite this. So I'm going to take this as 3. So therefore 3 is rewritten as pi times, okay, we have now 1 over 2 times ln modulus of 1 positive x divided by 1 negative x, right? So okay, I'm just showing you this, and the limits are 0 to 1 over root 3. Okay, we can substitute that limit. So 0 to 1 over root 3 followed by this quantity. Okay, I will have to integrate that, followed by integral 0 to 1 over root 3 dx divided by 1 positive x squared. So now we will have to substitute the upper limit. So this is going to be pi times 1 over 2 times ln modulus of 1 positive 1 over root 3 divided by 1 negative 1 over root 3. Okay, the modulus is running all through. So positive, this is going to be tan inverse of x, the limits are 0 to 1 over root 3. Pi is actually a product, pi is going all the way down, okay, over here. So if I were to read that, this is pi times 1 over 2 times ln modulus, this is root of 3 positive 1 divided by root of 3 negative 1. So root 3 gets cancelled, and this is going to be tan inverse of 1 over root 3 minus tan inverse of 0. So this goes off, this alone remains, okay? So this is equal to pi is actually flowing all the way through, right? So I will have to write this 1 over 2. Now tan inverse of 1 over root 3, that is going to be, okay, let me finish this off. Ln of root of 3 positive 1 divided by root of 3 negative 1. This is pi over 6. Okay, this is what we have now. So next what I wish to do is I would like to rationalize this quantity. So you have pi times 1 over 2 ln, you have root of 3 positive 1 divided by root of 3 negative 1. I will multiply by root of 3 positive 1 divided by root of 3 positive 1. Okay, of course the modulus sign is there, positive pi over 6. So this is going to be pi times 1 over 2 times ln modulus. This is root of 3 positive 1 the whole squared. This is going to give me root of 3 squared negative 1 positive pi over 6. So this is going to be pi times 1 over 2 times ln modulus of root of 3. Now if you want, you can actually square this up. So root of 3 squared positive 2 times the root of 3 positive 1 divided by root 3 squared is going to be root 3, right? Root of 3 squared is going to give me 3. So 3 minus 1, that's going to be 2. So this is what we are having, followed by positive 1 over pi over 6. So it's going to be pi times 1 over 2 times the ln root of 3 squared is going to be 3. 3 added with 1 is going to be 4. 4 positive 2 times the root of 3 divided by 2 positive pi over 6. Now 2 can be taken out, so you have 2 positive root of 3 divided by 2 modulus, and you have a ln, you have a half there, and you have a pi followed by pi over 6. So this 2 gets cancelled. So you have this quantity to be equal to pi 1 over 2 times ln modulus of 2 positive root of 3, right? This is what you got. Is there anything else we can do? We cannot do anything, so we retain it as it is, followed by positive pi over 6. Now we got all of this because we have to integrate this. Now after we have integrated, so what is this? This is nothing but 2 pi integral 0 to 1 over root 3 dx divided by 1 positive x to the raised to power 4. Now this is actually 0 here, right? It's understood. Now we take the value here and substitute it here. Remember this? We had this, right? So therefore 2 can be rewritten as 2 times I is equal to negative 2 times pi divided by root 3 positive 2 pi integral 0 to 1 over root 3 dx over 1 negative x raised to the power 4. So in place of this I'm going to substitute this. So this is equal to negative 2 pi over root 3 positive. So this is going to be equal to the value that we have here. So I will have it pi times 1 over 2 ln 2 positive root of 3 positive pi over 6. So this is what we got. On the left you have 2 times I. So we need just I. So therefore I is equal to 2 comes over here, so you have negative pi over root 3, positive 2 comes down, so you have pi over 2 of 1 over 2 ln modulus 2 positive root of 3 positive pi over 6. So this is what we have got. Now if you want, you can distribute this pi over 2 all through. So this is going to be pi over 4 ln modulus 2 positive root of 3 positive pi squared over 2 times 6 is 12. Now further, if you want, you can take this pi over 12 out. If you take this pi over 12 out, then clearly you have a pi here. Okay, fair enough, positive. Now I need to produce pi over 4 here, right? So that means I'm going to have a 3 there. So 3 times ln modulus of 2 positive root of 3. 3 pi divided by 12 will give me this value, right? If pi over 12 is being distributed in. Okay, fair enough. Now we need to also set this up. This is negative pi over root 3. So I'm going to have it as a negative 4 divided by 3, but there is a root 3. I need to get a root 3 there. Now since you have a root 3 in the denominator, I want to bring it in the numerator, so I'll have to multiply it like this. So this is going to give me root of 3 divided by 3. So the reason I'm placing here 4, because 4 divides 12 3 times. Okay, fair enough. So I'm going to have a 3 there, but apparently I should also have a root of 3 over in the numerator, right? So I need to cater to that. So the best way to cater to that is to have a product multiple of root of 3, right? Because we need a root of 3 over 3. So 4 times the root of 3 multiplied with 12. 4 divides by 3, so root of 3 over 3 is the direct outcome. Of course pi is there. So we are doing all these things because we need to get the required form. Okay, so this is the required choice that is being given in the question. Okay, and that is the conclusion for this beautiful question. And we started with this, and then we have to do all this, and then we came up to here, and then we have to resolve this, and we took that there, and we did all this, we came up to here, and then again we had to simplify all of this, and then finally we reached our destination. Thank you everybody. Please like, share and subscribe.